Hello everyone, I just realized for the previous video when we talked about the total serial we have in the data set, I use all the 77 serial in the data set, but see what happens. 3 of these serials are cold, right? So I couldn't use the total number of serial that I have in the data set. I had to subtract that from 3 to find all the cold serial. All the cold serial. So in total, minus 3 will be the cold serials, right? And then now I'm going to use the cold serial in the data set because I'm choosing those cold serial in shelf 1 divided by the whole number of cold serial I have in the data set, right? I cannot use those 3 that are hot. I'm just talking about cold cereal. So if I do this, the calculation will be a little bit different. So this will be the margin of error. So it's going to be 6 and 45. Okay. So now let's continue. Let's get all this information, copy it here, run this, and then, well, I want just 3 of them here. And then what I want to do, I want to copy all of these, and then now I want to find a confidence interval for those cereals that are in shelf 3. So those cereals in shelf 3 were 36, right? So 36, and what will change? Let's change all of these to 3 because we are calculating the proportion for all the cold cereal in shelf 3, right? Standard deviation will change, and we are going to use the 95% confidence interval. And what else? The proportion 3. And then here I'm going to talk about shelf 3. Okay, let's see. I hope I removed all of this. Okay, so now there are the proportion for cold cereal in shelf 3 is from 32% to 64%, right? Okay, so this is the margin of error for the cereal that are cold cereal in the shelf 3, and this is the margin of error for all the cold cereal in shelf 1. So if our margin of error is higher, which is 1. Let's say 20, right? We have a smaller sample size. We have 19. If the margin of error is smaller, we have a higher sample size. So remember 0.16. So for cold cereal in shelf 1, which are just 19 of them, we have a higher margin of error, which is 0.20. For the cold cereal in shelf 3, which has a higher sample size, 36, we have a lower margin of error, which was 0.16. So there is a kind of inverse relation between margin of error and the sample size. Okay, so now what I want to do, I want to find the confidence interval for the difference between two population proportion of cold cereals in shelf 1 versus shelf 3. So we have some information. We have proportion of cereal in shelf 1, in shelf 3. We have a standard error for shelf 1, standard error for shelf 3. We have this information, right? But let's see. I never printed out the proportion of cereal in shelf 3. Let's print this. And proportion of cereals in shelf 3. So what's the proportion of cereal in shelf 3? 0.48 or 49%, right? And then let's go back to see what was the proportion of cereal in shelf 1. What was that? 0.26%, or 26%. So 26% versus 48% proportion of whatever we have in the sample, right? So let's bring this here. We know this is equal to this one. We know this one is equal to this one. And then now let's print a standard error in shelf 3. So what is that? 0.083, right? And then I'm going to go back. For this one also, I'm going to get the proportion of, what's the standard error for cold cereal for in shelf 1. Okay, this one is equal this much. Okay, so these are the information we have. Do we need anything else? Look at this. So this shows the proportion difference between proportion of group 1, group 2. Then we need the standard error we calculated here, standard error here, z, and then we need the proportion. Okay, so let's do this. Okay, what I need here, is to create a variable standard error difference. How can I calculate this? That will be the square root of whatever I had under a square root for each of the group I had. So I want this but I want, because this one, this was the square root of proportion multiplied 1 minus proportion divide by n, right? So I want to get rid of the square root because I want just whatever I have under square root. So what I do, I will say this one power 2, and then this one also power 2. So means this one and this one plus each other. So now I have a standard error plus a standard error without a square root, and then I'm going to take a square root of the whole thing. Okay, so now I have a square root above that. So this will be the standard error difference, means whole part on this side. And then what else I need? I need the proportion difference. Let's call this also difference like this. And then I'm going to say proportion for the group 1 minus proportion for the other group. So proportion for group 1, proportion for group 3. Means I selected 2 groups, right? And then I'm going to use the whole thing here. I'm going to choose the standard, proportion difference minus or plus, like the formula here, then Z star, which is this one, and instead of standard error, I have to have the standard error of difference. I want to see what's the, oh, actually, that's good, that's okay. Okay, so let's see. Now, the difference between the proportion of population 1, the difference between population proportion for cereals in shelf 1 and cold cereal. And cold cereal in shelf 3 actually the confidence interval for the difference between population proportion for cold cereal in shelf 1 and cold cereal in shelf 3 is actually this much to this much. Okay, so now let me explain how to interpret this confidence interval. How do I interpret that? Okay, so first of all, we want to talk about the null hypothesis for this kind of a study. The null hypothesis says the population proportion for cold cereal and the population proportion for the cold cereal in shelf 3, so in shelf 1, and the population proportion for the cold cereals in shelf 3 are not different. Or we can say, or the population proportion for cold cereal in shelf 1 minus the population proportion for the cold cereal in shelf 3 is equal 0. So you can imagine like this, P1 minus P2 is equal 0, right? Or P1 is equal to P2. So when I say are not different, means this one. When I say the difference is 0, means this one. Correct? So now, because, so this is our null hypothesis, right? Now, because this confidence interval, because this confidence interval contains 0, we can say there is no difference between these two cereals in shelf 1 and shelf 3. We can explain this in different languages. We can explain this in different words, but the most important thing is to understand what happens if our confidence interval contains 0, means it's a negative number is a lower bound and positive number is an upper bound. Then we can say there is no difference between the two groups, or the two groups are the same, or the proportion of cereal, of cold cereal on shelf 1 is same as shelf 3. We could say it in this way. Means the both proportion are the same, or there is no difference between. This one says there's no difference between the proportion, and this one says the same thing in different word. It says the both proportion are exact the same. Okay, so if there was no 0 in the confidence interval when we are comparing the difference, we would say there is a difference between the two groups. There's a difference between, for example, cereal in the shelf 1 and shelf 3. Okay, so now we can actually, let me see. We calculated the proportion, and let's see what else remained. Okay, so I wanted to show you how we can calculate the 95% confidence interval for example, this one, using a stat model package. Okay, so let me create using stat model package. Which one is that? Let's bring both of them in case I need them. Here. Okay, so there is a method in stat model package. We use stats dot proportion underline confident, actually CONFINT, and then we are going to use this one, and actually this multiply this one to the proportion of serial in shelf 3, and then second argument is again the number of cold cereal in shelf 3, and if you compare the confidence interval with this one, you will see they are exact same. Using a stat package to find the confidence interval for the proportion in population. Proportion of population sounds better. Okay, so let's call this CI and then print CI. That's much better. Okay, so this is the way we use a stat package to find the confidence interval for the proportion. So we have two arguments. The first argument says number of items in a group multiplied by the proportion, and then the next item says the number of items or observations. Okay, so now so far what we did, we calculated the confidence interval for proportion just for one group separately, and then we calculate the proportion difference of proportion in the population, the confidence interval for that, and then all of them we assume the confidence level is 95%. We use this. So now we want to find the confidence interval for population mean, mu, and the population mean difference means the mean difference between two groups of in the population. So what we have here now, we want to find CI for the mean of population. Okay, so let's do something interesting. Okay, first of all, because I forgot what we had in our data set, so let's use data set dot describe, I hope I'm right, to get the information of some column in the population. See what we have. We have calorie, protein, fat, and rating. So let's be more specific. Let's see what we have in rating. So it says we have statistics for rating. Okay, so we have minimum rating to be 18 point this much. The max rating is this much. And then the mean rating is this much. Okay, so what I'm going to do here, I'm going to separate the rating to two kind of groups. First of all, I want to say, okay, there's a variable mean of ratings, and that's the dataset dot rating dot mean. I think I'm right, and I'm going to print this, and this must give us the rating, mean rating, this one or this one, right? I'm going to get mean ratings. I'm going to get high rating or high rate, and I'm going to separate the data set to the ratings that are above the mean of rating. This is the group that are group of cereal that has a higher mean of rating. So these are all the ratings for these cereals. And we have all the name of cereal. So I want to see what is the mean of this rating. Mean of rating. I'm creating variable np dot mean. And then this one. Okay, so what actually I wanted to do now came to my mind. I'm going to change something. So I'm working on the rating, right? I want to actually find the calories for those with high rating and the calories for those with a lower rating. So let's do that. That's more interesting. So what I want to do here, I will go back to the column and see what was the name of calorie. So I'm going to just separate the data set for the calories that have a rating above, what is that? Above 42. So I'm going to write down here. I chose the high rating cereal above average, right? I chose. the calories for high rating cereal. Correct? Okay, so now we will continue. So what I'm going to do, Control Z, and then I'm going to now continue finding, actually first let's find the high rate mean by choosing high rate dot actually we can use np dot mean and high rate, and then I'm going to print the mean for this high rate. The mean is 92 calorie. This is the mean of calorie for the high rate cereals. And then what I'm going to do, I'm going to find the standard deviation. Instead of mean, I'm writing down the standard deviation. This is the standard deviation. So standard deviation is 17 for high rate cereal. And then what else I'm going to do, I'm going to find the number of let me see if NP has count. I'm not sure. No, it doesn't. So what I can do, I can say high rate count. This will give me the count. This is the number of calories, number of actually cereals that are high rate. Okay, so the count is 30. So I have the mean, I have the count, I have the standard deviation, and let's calculate the standard error. We show that with SE. Standard error, we show that with SE. SE. So what is the standard error? In this formula on the right side of the screen, we see that S divided by square root of n. So we will choose the standard error, divide by SQRT of the number of high rated cereal. Correct? Actually NP SQRT. I think now it's correct. This is the standard error. So standard error is 3.2, which is this one. What else? I'm going to, what else? Now I'm going to find the lower and upper bound. I want to copy this, bring it here. We don't need the proportion because we are talking about the mean. Okay, so now I'm going to look at this. I have the mean calorie plus and minus Z is equal 1.96 for 95% confidence level. Confidence interval. And then here I have S over square root of n, which I calculated to be standard error. And then now we have the lower and upper bound of population mean calories for the high rated cereals. Okay, so the high rated cereal with 95% confidence interval has a mean calorie of 85.7 to 95.2. So we are 95% confident that the high rated cereal has a calorie between this one and this one, right? So now what I want to do, I want to calculate all of these for the low rated cereal. Calculate the CI, the 95% CI for the high rated cereal percent CI for the calories of high rated cereal. Still calculate the 95% confidence interval for the population mean for calories of high rated cereal. Now it's correct. And here I'm going to calculate it for the low rated cereal. So how did I separate the high rated cereal? I had the mean rating, and then the high rate cereal was all the calories for cereal that are above, has a rating above the mean rating. Here I'm going to say less than equal to, right? And then instead of above, I'm going to say below average, right? And then everywhere I find high, I'm going to, can I replace it? I cannot. So I wish I could. Instead of high, I'm going to write down low rated. Low rated and low rate everywhere. I'm going to stop and come back. Okay, so what I was doing, instead of low, I wrote down row. So that's why everything was kind of, I had to redo everything. Okay, so what I did to make sure I don't have any misspelling, I restarted kernel and then run that first line again, and then came back here and run this again. So if I didn't have any error, everything was fine. So I'm going to go back, actually run all of this all over again because I restarted kernel. Okay, so here high rated, so now what is the wrong thing here? In line 7, high rate mean, and then high rate is not defined. Why? Oh, My God, did I even remove that line? I think I did. Okay, let's do this again. See, that's very good because you will realize where is the mistake, or accidentally if you did anything wrong, you can come here and fix it. And then here this one was above average. Let's see what's wrong. Okay, good. Okay, so I have the calorie confidence interval for the mean of calorie for all the high ranking or rating cereal, and the confidence interval was this much calorie to this much. And then I have the confidence interval for the mean of calorie for all the low rated cereal. And look what happens. The low rated cereal has higher calorie in compared to the high rated cereal. That's very interesting. So we will see why some of the product are more has a better quality, and therefore they have a better rating, right? And some other product has a lower rating, and obviously they have not good quality. So I assume that like fat is higher, or sugar, or all of these kind of things that leads to the higher amount of calorie causes that kind of calorie increases like this. So we are 95% confident that if we choose a low rated cereal in a market, the calorie and the mean calorie for those low rated cereal will be between 112 to 120. So now let's use this formula to find the mean difference of the calories for high rated and low rated cereal. So what I need here, I need actually CI for the mean difference of calories for the high rated and low rated cereals. Okay, so what I need here, look, I need to calculate the mean difference. Mean difference, what was the mean of low rated here? This is a low rated cereal minus, where is the high rated cereal? Mean for high rated cereal, this is the mean. So this is the part x bar minus x1 bar minus x2 bar. And what I want to do, okay, oh, I forgot to talk about this. Okay, so look at this huge kind of, what is that? Part 2 of this formula. This is for actually this formula. This is standard error part of formula is for two groups that the sample variance of them are not same. Then we call this unpooled approach. So when I say sample variance, look at this variance we have here, a standard error for low rated and standard error for the high rated. So of course their sample variance are different. This high rated has a higher sample variance 3.2 and then actually standard error. And what is the sample standard error? You know what I want to do? I want to print a standard deviation. so this one is more clear. And this one is a standard error. And then I'm going to do the same thing here. This is a standard deviation. This one is a standard error. So look, a standard deviation for high rated serial was 17, for low rated serial is 13, a standard error is 1.9, a standard error is 3.21. And the actually sample number is also different. This one we have 30 of them, this one is 47 of serials. Okay, so when sample variants are different in two different groups, we are going to use the unpooled approach. Means we are going to use this kind of formula for the standard error. You can easily Google it and see when the sample variance is similar for two groups, how we can find a confidence interval for the mean difference. You can easily find all of this formula online. Okay, so because actually this formula is very huge, so I want to write down SE part 1 and SE part 2. So the part 2 is very easy. I'm going to use NPSQRT and I'm going to use two parentheses, one and another parenthesis. This one will be 1 divided by the sample size for the first group, sample size for the second group. So what was the sample size? We calculated with count. Do you remember this one? Okay, low rate N. So low rate, and this one is going to be high rate, correct? And then for this one, np.sqrt, and this will be a huge formula. So first of all, I'm going to write down the denominator, which is very easier, n1, which is this one, plus n2, which is this one, minus 2. So this is the denominator, right? So let me, okay. And then numerator, I have n1 minus 1 multiplies to standard deviation of 1 power 2. And then plus, so I'm going to put this in a parenthesis and then show you I divided this to two parts. Okay, so this will be the numerator, and I'm going to put the numerator in a whole parenthesis. Okay, I hope this was clear. So I have a whole parenthesis for numerator, and then I have one part, this one, another part is this one. And then in first part, I'm going to say this one minus 1. For the second part, I have sample size minus 1. So n1 minus 1, n2 minus 1. And then I need a standard error for the first one, power 2. What is the standard error? No, sorry, that's a standard deviation. Standard deviation goes here. And then for the next one, standard deviation for high rated, power 2. Okay, I hope I don't have any mistake. Okay, good. So I didn't have any mistake. So what was the SE difference? Will be this one multiplied to this one. And then how can I find the lower and upper bound? I'm going to use the mean difference for each of the formula, and then z is equal to 1.96, and then what is the standard difference? Is this one. Okay, so this is the formula. Plus minus mean difference plus minus z multiply standard error difference. So let's see what we have. We have 17 to 31. Do you see that? So this is the confidence interval, 95% confidence interval for the mean difference of the calories in high rated versus low rated cereal. Okay, so do you remember I said if there is 0 between these two numbers, means 0 contains in the confidence interval, we can say the two groups are similar. But here there is no the confidence interval doesn't contain 0. Therefore, the two groups, what are the two groups? Low rated and high rated cereals have different mean of calories in the population. Okay, so I hope this actually makes sense, because we saw how the confidence interval for the low rated and the higher rated cereal were different. And now we see that yes, these two groups, the mean calorie difference is definitely not similar for high rated cereal and the low rated cereal. Okay, I hope this makes sense, and if you have any question, please let me know. Take care of yourself. Thank you.